Hi, my name is Si-Young Ri, and I'm a Senior Technical Product Manager in Microsoft Advanced Analytics Marketing team. Today I'm here to give you an introduction and demonstration of advanced analytics in action for retail, healthcare, and manufacturing. The three demos I will be showing you, the first will be on perceptual intelligence. Perceptual intelligence is a new area where things like speech, text, facial, and object recognition technologies are combined to predict and find insights in various types of data. I will be also showing you a second demo on predictive maintenance. Predictive maintenance is a common scenario for manufacturing where users and business users alike can find and predict future outcomes of various things that might break down and be able to prevent those things from happening in the first place. And finally, I will be showing you a personalized healthcare demo for the healthcare industry based on our recent Dartmouth-Hitchcock case study. All right, so for our first demo on perceptual intelligence, this is the howold.net site that some of you may have been familiar with. For those who aren't, let me give you a quick recap. I can search for photos, such as my own. And when I use this photo, the system will try to find the gender and the age that I look like. Now this one was pretty accurate, but behind the scenes, it is using the power of perceptual intelligence to use facial detection and recognition. And by using complex algorithms, it will find out what it thinks I look like. The magic behind this application is that it was created by a very small number of developers in a very short amount of time by utilizing the APIs that Microsoft has created before. If you go to Cortana Analytics Gallery, as I show you here, Microsoft has created out-of-the-box APIs that all users and developers alike can add to their applications. So for example, if you'd like to add a face recognition to your application, simply click on this API and you will be able to add it to your application. Inside this API, we already have all the necessary tools to recognize faces and figure out their age as well. For example, if you also like to add sentiment analytics to your application, you can click on text analytics and use this and add it to your application as well. We can try a simple demo here. Let's say I have a hotel website and I'd like to analyze the various feedback or on the website. And so maybe some of the feedback is something like, I love this hotel. And it will show me that I have a 91% positive sentiment. But if I change the words to, I hate this hotel, you will see that it's very negative with only 2% of sentiment. As you can see, we can very easily add these types of perceptual intelligence to your applications, your websites, and various types of information to superpower your applications for everyday use. Now, as the howold.net site got very popular, we created another website called celebs.likeme, timed for the Oscars. This time I'll search for my photo again. And when I use my photo, it will try to match the closest looking Oscar nominee that my face looks like. In my case, it was Adolf, closely followed by Masioka as 54%. Something that we had some fun with using the power of perceptual intelligence. So there we go. That was our first demo on perceptual intelligence, where users can use natural interfaces to find insights. So now let's take a look at our second demo on predictive maintenance. All right, for the second demo, I'll be walking you through a predictive maintenance scenario. Predictive maintenance is very commonly used in the manufacturing industry as well as other industries, and it is about being able to predict future outcomes and, if possible, to be able to prevent those from happening in the first place. Now, this scenario is based on vending machines that are installed throughout the state of Washington. And we're trying to figure out which vending machines actually broke and going further, which vending machines might fail in the next few weeks or the next few months as well. And based on those predictions, we may be able to create an optimized route plan to do those fixes. The dashboard you're seeing here is an overview of what our business looks like. For example, I'm very interested in some of the lost sales that our vending machines are occurring. So I can do a simple natural language query such as lost sale. I can view this by beverage types. And since I like pie charts, I can add it as a pie chart. I can simply pin this graph to my dashboard. But going back to our dashboard, I can see in the top left corner that there is a huge gap between our forecasted sales and our actual sales. So this worries me, so I will drill down further by clicking on this chart to get some more details. As you can see, throughout the last 3 months, there are small dips and gaps between the forecast and the actual sales. Right, so this is a detailed view of the hundreds of vending machines that we have, and we have ID'd each of the vending machines with numbers. For number 41, for example, the forecast and the actual are perfectly aligned for the last 3 months, but in middle of June, the actual sales drops. That's very interesting. Let's look at another one, 82, which is similar, but it also has a big drop in April as well as in late June. And the vending machines that are clustered in the top left corner are actually the ones that are incurring the most loss in sales. And so these guys are the ones that we are concerned with. Let's look at a bit more detail in each of the vending machines. So we rank the vending machines by the ones that cost us the most. Our usual suspect, number 41, is located in Seattle. And as you can see, all of our vending machines have sensors attached. We've added temperature, vibration, power, voltage, and duty cycle. Now, as you can see here, just before a vending machine breaks down or incurs loss in sales, there's a very strange pattern in our sensors. Temperatures shoot up, power shoots down, voltage drops, duty cycles go haywire, and so we can assume that there must be some pattern of these sensors just before a vending machine may break down. And so let's create a model to see if we can predict those outcomes. So this is where the power of machine learning comes in. By being able to model such predictions, we may be able to predict the future. When creating a model in the Machine Learning Studio, we can start with other samples that Microsoft and other experts have created, or we can create a blank experiment. So this is the machine learning canvas, and you can create a model simply by dragging and dropping the modules on the left to the canvas in the center. I've already uploaded my data set, so I'll simply drag and drop this to my canvas. Let's take a look inside. So here's my data. I have various data sets, various columns. Some of the ones I might need, some of the ones I might not need, but I'm sure I need the status, which is, did the machine break down or not? I have the 5 sensors, voltage, power, duty, vibration, and finally temperature. So what we're trying to do here is, we're going to try to predict status using these 5 different sensor types. Now I don't need some of these columns, so I'm going to do a little bit of data cleansing or feature engineering as they used in machine learning world. I'll use the project columns module and hook it up with my data set. As mentioned before, I will trim down the number of columns I need by just selecting status, voltage, power, duty cycle, vibration, and finally temperature. I'm good to go. So now that I've trimmed down and cleansed my data set, I'm ready to start the machine learning modeling process. But before I do that, one very important step in machine learning is being able to split the data and compare it with the predictions. I put the split data module underneath and hook it up with my new data, cleans data set. I can divide it 50-50 or 80-20. There may be many philosophies or standards used depending on the scenario. We'll leave it at 50-50 for now. What that means is half of the data will be going out in the left number 1 output, and the other half will go out in the number 2 output. We are now ready to train the model. So I will plug in the left half into my trained model, and at this point I'm going to select an algorithm to train the model with. The Machine Learning Studio offers a whole bunch of built-in algorithms for everybody to use. In our case, since the way that vending machines can break down are multiple reasons, we will be using a multi-class decision forest. And I can simply hook that up to my train module. And it will ask for me what I'm trying to predict against. In our case, we will be the status. Finally, I would like to score to see how accurate my model has predicted. I'll drag that into my canvas, hook up the output of the trained model, and compare it with the other half of my data. At this point, I'm pretty much done with my predictive modeling. To recap, I've added my data set. I've cleansed it a little bit, just to the columns that I need. I split the data between half and half, using the first half to train my model with a multi-class decision forest algorithm, and I've compared it with the other data to see how well my model has predicted. Let's take a look inside. So as you can see here, this is the status, this is the output, and I'm using these 5 columns: voltage, power, duty cycle, vibration, and temperature. And based on these output, I have a score label, and accuracy is calculated by seeing how much of my scored labels matches with the actual status. So now that we've created the predictive model, we can go back to our dashboard. So this is a predictive dashboard, and let's say today is April 1st. Everything is normal. All of my vending machines are humming along perfectly. But tomorrow, on April 2nd, I will have a problem with number 36. It will have a broken seal, and there are a few spare parts that may need to be repaired. Let's go down to May, a month ahead. If nothing was fixed by May, we will actually predict that 3 machines, 44, 34, and 42 will break down, and these are the spare parts that will be needed. And we've also indicated the loss in sales that these will incur, so you'll be able to create an optimized route plan to fix these before they actually break down. Finally, the question comes up, so if you've already fixed a vending machine before they broke down, how do I know that they actually was effective? And so we created a report to compare the different results between just bare bones, with IoT, and finally with machine learning. With just a dashboard, the green line is the expected sales that we see. With Internet of Things technologies, which is the sensors that we've attached, we have a higher revenue expectancy than just with BI. And finally, with machine learning, by being able to predict and prevent the machines from failing, we have a less gap, or we have less fluctuation between the 3 months that are expected for our revenue and sales. So that's a wrap for our second demo on predictive maintenance. And for our final and third demo, we'll now introduce you to the personalized healthcare demo. Okay, so we're ready for our third and final demo on personalized healthcare. This demo is special because it's actually based off of a real case study that we did together with Dartmouth-Hitchcock hospitals. They are an advanced hospital where they use technologies like machine learning to be able to predict which patients are doing well, which patients might be readmitted, and so on and so forth. Let me log in to the patient portal as a nurse and see what's up. So this is the Mission Control Center, and you can see on the left the various patients that we monitor, and you can see on the right the various reports and issues that may occur for each of our patients. You'll see that a very big interest recently is the readmission rate of patients. It would be best for both the patients and the hospitals if patients do not have to be readmitted to each of these hospitals. You can see here that Ben Andrews has an 89% chance of readmission. So let's click on Ben. So here's Ben's detailed patient dashboard. We are integrating data from many sources, including Dynamics and CRM. In the case of Ben, he has congestive heart failure, hypertension, and various other issues. We can click on Ben's heart and see his heart rate, blood pressure, his weight, and so on. We've also gave Ben a Microsoft Band to measure his heart rate in real time. We also have the company application that Ben can use to track his mood. In this case, we can see his mood has been changing throughout the last 48 hours. We can also monitor his sleep cycle, his activities, as well as heart rate in real time. We also noticed that his weight was reduced, but also been gaining in very recently as well. Using machine learning and clustering, we've analyzed both Ben's friends and his neighborhood to see what the average blood pressure is for his age group. We also noticed that his blood pressure is a bit higher than the average, and what's very concerning is, based on our predictive modeling, his blood pressure is projected to rise even further in the next 48 hours. So this is Ben's detailed report, and based on his blood pressure being projected to increase in a great amount, his weight being increased in the last 48 hours, and his mood being dropping like this, there's a very high chance, or 89% to be exact, of Ben being readmitted to our hospital. So as a nurse, I'd like to adjust his care pathway. I can make contact with the patient or his guardians. I can make some notes, and then I can save this here. I can adjust his prescriptions, or also his wellness goals. I can make him walk more or add more minutes, and then make various adjustments to the pathway. So now that I've made these adjustments, we can go back to the dashboard and see that Ben's issue is now being resolved. We hope the best for Ben and that he won't have to be readmitted to our hospital. All right, so that's the end of the third demo on personalized healthcare. As a call to action, I'd like to let you know that by now, you may have heard of our new name of Cortana Intelligence Suite. Feel free to go to Microsoft.com to learn more about our new products, as well as Azure.com to learn the technical details of the new suite. Thank you so much.